Wakata Stadimator and presenter is Kubro. As I have said earlier, our today's lesson will focus on some concepts on mathematics. Okay, some concepts on mathematics, and that those concepts will be about GCF and LCM. Okay, when we're in the lower grades, you know that what GCF mean and what LCM mean integrally now. Okay, زعاوية حوار مقالي زناسة حوار ربح. In grade 6, 7 or 8 you have learned what GCF and LCM mean, and now I'm going to clarify one by one. Okay, when we say GCF is greatest common factor of numbers. We are talking about numbers. Now, greatest common factor of a given number and the least common multiple of a given number. We will see how to find the greatest common factor and LCM of a given numbers, two or more than two natural numbers. And after finding those GCF and LCM, we will see what is the use of finding GCF and LCM for our further computation or for our further calculation. Okay. Now, let's see some counter example. I will show you about two numbers, okay? Example, the GCF of 3 and 12. If I say find the GCF of 3 and 12, I do have different techniques. One, I can list all the factors of 3 and 12 and then taking the greatest of them. Or I can use the prime factorization. Okay, for today I'm going to show you the prime factorization method. Okay, the prime factorization method of 3 is itself 3 because 3 is, as we have defined in our previous discussion, 3 is a prime number, and hence this 3 can be described by its prime factor 3, as well as 12 can be described by prime factorization. We have a rule. 12 will be as I have said earlier, the smallest prime in our natural number is 2. Okay, so I'm going to begin by 2 since this 12 is divisible by 2. When 12 is divided by 2, it will be 6, and again this 6 is composite. Okay, so to be expressed in the form of prime numbers, we are going to divide it by 2. Since 6 is divisible by 2, again by 2 it will be 3. Now we will stop our prime factorization because this 3, the number on the right hand side is prime number. Okay, so 12 can be expressed in the form of prime numbers, product of prime numbers 2 times 2 times 3. Hence this is 2 to the power of 2 times 3. Now I'm going to put this 3 in its place. Okay, now to take the GCF, we are going to see that prime factor should available on both numbers. Okay, otherwise we do not take it. So when we see 2 is only present in 12, but it is not on the above number 3. So it is impossible to take 2 as a GCF. Okay, and then we are going to the next number, which is 3. 3 is available in both numbers, and it is the power of 1, the power of 1. There is no difference. 3 is the power of 1 and 3 is the power of 1. 3. Therefore, the GCF will be the GCF of 3 and 12 will be 3 itself. Okay, 3 itself. But when assume that having 2 here, if you have any number 2 here, we are going to take the smallest power. Okay, the smallest power. Let's say if we have 2 to the power of 1, we are going to compare 2 to the power of 2 and 2 to the power of 1. Although the name says greatest, what we are going to make on our technique is taking the smallest power. We will take 2 to the power of 1. Okay, but now we don't have any 2 here, therefore the GCF is 3. And next, LCM. Simply we can take the LCM of those numbers. Again, as I have said earlier, it is possible to list the factor, the multiples of 3 and 12 and take the least common of them. Okay? And but by now I'm going to show the prime factorization as GCF. Okay? 3 is 3 and 12 is to the power of 2 times 3. Then it is time to take the LCM. Okay? Now it is possible to take 2 to the power of 2 as it is, even though it is not present in the first number. Okay? In LCM it is possible. If it is present, we will take the highest power opposite to the GCF. Okay? But in case of LCM, we are going to take the highest power in case of using prime factorization. Okay? This is a prime factorization. Okay? So here we are going to take not to present here, we will take to the power of 2 as it is. This is to the power of 2 times from 3, they are equal. We are going to take 1. Okay? This is 3. As I have said earlier, we are going to take the highest power. If we have to the power of 4 here, it was taken to the power of 4. Okay? But by now, this will be 12. Now, my LCM is 12 and my GCF is 3 of the numbers 3 and 12. This is using the prime factorization technique. But we have another technique also. It is possible to list the multiples of 3. We are going to start from 3, then 6, then 9, then 12, and so on. And 12 will be 12, 24, 36, and so on. Then we will take the list of them. Therefore, the list of them is 12. But now, this is how to find the LCM and the GCF of a given number. 2 or more than 2 numbers, okay? But then what? What is the benefit of GCF, finding GCF and the LCM in our further calculation is the most important thing, okay? So finding GCF helps us to simplify a given fraction, okay? You know, a fraction is expressed in the form of A over B. So in order to put it in its lowest form or in its simplified form, the numerator and the denominator are going to be simplified, okay, cancelled out by the GCF. So finding GCF is mandatory, okay? And if you ask me, what is the benefit of finding LCM? Also, you know that you are going to compute rational numbers with different denominators, okay? A over B plus C over F. Now, the denominators are different. So we are going to take the LCM of DF by this technique and then adding or subtracting. In case of multiplication and division, it is easy. But when we come to addition and subtraction of different denominators of a given fraction, it is mandatory to know how to find the LCM. Okay. Now let me give you here 3 over 12. If somebody asks us to simplify this 3 over 12, it is mandatory that to find the GCF, okay? And as I have said earlier, the GCF is 3. What does it mean? It is possible to divide 3 by 3 and 12 by 3. It is common for both of them, since it is their GCF, okay? So by 3, this is 1, and this is by 3, 4. Therefore, this is the simplified form of this rational number or this fraction, okay? And again, I'm going to show you another 1 over 3 plus, in case of plus 2 or 5 over 12. Because I want to use those numbers, okay? I want to use those numbers because we have already found that the LCM is 12, okay? Now, to find we have different techniques, different systems, but for today, I'm going to show you how to find by finding the LCM, okay? Now, as I have said earlier, the LCM of 3 and 12 is 12 itself. Then this is 12. 12 divided by 3, you know that, the steps, okay? It is 4. 4 times 1 is 4. Plus 12 divided by 12, it is 12. Okay? 12 divided by 12 is 1, sorry. 1 times 5 is 5, okay? Now, this becomes, adding the numerator, it will be 9 over 12. Now, it's possible again to simplify this because 3 is the GCF of 9 and 12. By 3, 3, and by 3, 4. This will be the simplified form. So today we have seen that how to find the GCF, okay, and how to find the LCM of a given number using prime factorization. Okay, students. Now you are going to strengthen this in your home, at your home, by practicing more and more. Okay, and by asking your teachers as well as your parents or friends around or surround your neighborhood. Okay. So this is all about today. But for further discussion, let me give you homework. Okay. Now this will be as usual. I'm going to give you a homework. Find the GCF and LCM of 15 and 305. What is the GCF and LCM of 15 and 305 using the same method as we have seen earlier? Okay, you are going to put this one in the comment section, and I will give you feedback when you put your answer in the comment section. Okay, for today, this will be my end discussion. Next time we will meet with another concept, a mathematics concept. I was Kubro, and if it is valuable, you can like, share, and subscribe. Okay, for today, bye. Goodbye.